What's going on, everyone? My name is Johnny Bandon, and I'm your CCNA instructor for this CCNA video series. In this video, we're finally moving on or away from the fundamentals of 802.11 and wireless LAN networks, and now getting into the architectures and the different deployments. So in this section, we're going to go over the different AP modes, we're going to go over the 802.11 standards, and then we're going to go over the different wireless controller deployments, which kind of tie into the AP modes, but we'll dive a little deeper into what CAPWAP is, what the Cisco Unified Controller is, and then a different way to set up a wireless LAN controller. You know, we have embedded controllers, we have a virtual controller that you could put on like E6i, and then we have physical hardware, that's like the Cisco Unified Wireless LAN controllers. So actual, device looks like a switch or looks like a router that you actually put up in a rack, and that is your wireless controller. So with that being said, let's go ahead and get started. So the first thing we're going to talk about, again, is going to be our wireless standards. So just kind of going over our agenda here. We're just going to hit real quick 802.11, go over like the different gigahertz or the different frequency ranges, the alternate names you call 802.11 AC, AX. So, Wi-Fi 5 and 6 and 4. Because that's kind of the common terminology you're going to see, Wi-Fi 6. And then we're going to go over the different AP modes. So there's 3 different ways to deploy an AP or to set it up operationally. That's autonomous, lightweight, and then a cloud-based AP. We're going to go over the differences between those. And then we're going to go over WLCs and different types. So it just has unified here, but I'll just touch on embedded and like the virtual WLCs. For the CCNA exam, don't know if we'll need to be that in-depth on different WLC types and information about wireless LAN controllers. What's important for this one, or this section, is really those AP operational modes and the Wi-Fi standards. So let's go ahead and jump right into the 802.11 standards. And what I want to touch on here is really the standards and their frequency ranges. That's what I think is important for the CCNA exam and the max data rate. So what I want to go over here is we're going to start at 802.11b. This was made probably like early 2000s, and this runs in the 2.4 gigahertz range only and offers really low throughput or max data rate. And then moving on to 802.11a, this was the first introduction as a Wi-Fi standard for the 5 gigahertz range and its 40 megabit channel widths, and that gave us 54 megabits per second. Then 802.11g, which was actually 2.4 gigahertz range, and that gave us also 54 megabits. But it made this possible because of introduction to technologies like MIMO and going over different modulation that allowed a shorter channel bandwidth in the 2.4 gigahertz range, talking like channel 1, 6, and 11, be able to deliver the same speeds. And then 802.11n, which is like the lowest standard you're going to see nowadays that wireless networks even operate on, that I have seen, is going to operate in the 2.4 and the 5 gigahertz range. And you have a max data rate of 600 megabits. And you get this from your 5 gigahertz ranges. You're not going to get that much on the 2.4 gigahertz channels. An important thing to note, in some environments, if you have an old workstation, that maybe is only doing 802.11b, some access points will actually downgrade everybody else down to that 802.11b standard. So it's just important to note these things, right? That if everyone is doing 802.11n, and then you have one station that wants to do like 802.11 AC, you're probably always just going to get N. And this really just depends on the access points, what vendor, what year that access point came out. Just wanted you to be aware of that, right? And then the alternate name for 802.11n is Wi-Fi 4. And then we have the upgrade 802.11 AC, which is going to operate just in the 5 gigahertz range. It says this is the max data rate. I mean, I don't know if you mean maybe in a perfect world. And that's Wi-Fi 5. And then we have 802.11ax. This is going to actually operate in 3 different channels or 3 different frequency ranges. And then for the max data rate, it says 4 times 802.11 AC. What that means is essentially this is really fast. It doesn't mean that you're getting 24 gigs of throughput. This means that if you have an 802.11ax access point, and it's running, and that's what your Wi-Fi enabled endpoints can do, you can have 4 separate endpoints all getting that 802.11ac speed. And then that's called Wi-Fi 6. Along with these improvements also came security improvements. So typically with like 802.11n and AC, you're going to see WPA/WPA2 for encryption. And then for Wi-Fi 6, you actually get WPA3. And there's going to be some major differences between these two that we'll go over in our wireless security section. Just wanted you to be aware. Now moving on to our different modes. So we're going to start out in autonomous mode. So kind of let's recap what an access point is and what it's doing. So an access point is that bridge for our Wi-Fi clients and our distributed network or distributed system. That's the more common term you're going to see. And this access point is going to send 802.11 frames to the Wi-Fi clients, and it's going to give them access again to this 802.3 wired network. Now with an autonomous access point, this is going to be an access point that operates independently without any need for any sort of brain or controller sitting out there on the network. So what this means is that an autonomous access point is responsible for managing all aspects of the wireless network. It can do the layer 2, the layer 3. It could also just, of course, be that bridge. And with an autonomous access point, we would have to actually web GUI or reach that access point via CLI directly. Now, what are some challenges you already kind of see with this? Well, if this autonomous access point is doing everything, right? You have to create its profile individually. You have to do the security, set up its mobility. And then let's say we add in 3 more autonomous access points. Well, now you have to manage all 4 individually. You have to make sure their channels aren't stepping over each other. So that means you have to go through the entire configuration process 4 times, 4 different times. There's no way to kind of build a profile that can be pushed to all 4 because there's no controller involved. So configuration and management are done either through that GUI or CLI at each individual access point. And then we may not even be able to give our customers any roaming capabilities unless we're like meshing with these access points and sharing that basic service set and allowing an extended service set, which typically can be done with autonomous access points, but you get this really kind of flaky mesh network. And again, really hard to manage. So this autonomous access point is really for that small to mid-sized business. And really, this like diagram I have up here, we just get rid of this distributed network. An autonomous access point is probably what you're running at your house that connects to a modem, and that's your entire distributed system there. And then the modem sends it out to the ISP. So what you typically see at your home networks is an autonomous access point that does everything: the routing, the security, the layer 2. It just uses one broadband connection to get connectivity out to the internet. Some more things about autonomous access points. They can operate in a standalone environment, so kind of like your home network, or they can be part of a larger network. So it is possible, like I said, that we can set up other autonomous access points and do this kind of mesh network where they're sharing information with each other. But again, they're only individually managed. So that means I have to go to my computer and web GUI or CLI into each one of these access points. So this solution is really, again, for the small, and I use this very cautiously, medium-sized wireless networks, because essentially once you get past like 2 or 3, it's time to start thinking about some controller-based solution for your access points. So they have limited scalability, and for any large enterprise, and I consider even medium enterprises, you don't want to use autonomous access points. And with the way that deploying controller-based wireless networking is so easy nowadays, in any really even small business, you kind of don't see this anymore if they care about their IT systems. Even in my personal home network, this is going to sound sacrilegious because this is a CCNA course, but I use UniFi. I have a Dream Machine. And I don't even know if they sell access points that don't operate in lightweight, that aren't getting all controlled by my router, which is the unified Dream Machine. And it was easy to deploy. I mean, really simple and way better than a regular like wireless router or access point I get at like Best Buy or something. And very similar cost. So really the autonomous access point, it does have its use case. And that's really when you're looking for something cost effective, where you have a customer that's like, hey, I don't want to spend too much on my infrastructure. All I need is my 5 computers or my point of sale systems up and running on Wi-Fi. Okay, let's just go get you an all-in-one solution. So again, in autonomous mode, you do have the ability to kind of mesh all these together and then sync up information to this distributed system. So one thing that we're going to point out here is kind of the traffic flow. So let's say this computer is connected to the sales VLAN, and then this computer is connected to the management, and this computer is connected to sales. So when we have an autonomous access points, even if they're set up like this, set up to the distributed system, if both these computers are connected to this basic server set, let's say from this AP4, when it needs to talk, let's say this is PC1, PC2. When they need to talk to each other, the traffic flows like this. And why is that important? Because essentially this is taking the layer 2 capabilities away from like what would be our access switches here. So it's allowing just connectivity locally at that access point. And then let's say this computer needed to talk to this management computer over here. So different broadcast domains, right? Different subnets. It would flow up to its default gateway, which is more than likely going to be these layer 3 switches, and then back down this way. Now, why is this important to note? Because when we talk about lightweight, we kind of compare and contrast autonomous to lightweight mode. All that traffic flow I just showed you gets replaced by this WLC. And we're going to go over that. All right, now jumping into lightweight mode. So in lightweight mode, an access point is going to operate under the control of a WLC, meaning that this access point is just a big dummy, right? It's handling that 802.11 like association and control. It's doing the RF. It has the antennas. It's propagating the RF. But when you built its profile, when you configured all the wireless LAN networks, it's being done from this guy right here, the WLC. And that's going to be responsible for managing the configuration, operation, and security of the wireless network. So if I want to employ WPA3 and only have 802.11ax running on my access points, and I want 2.4 gigahertz for the sales VLAN and 5 gigahertz only for the engineering VLAN, I do that all from here, the wireless LAN controller, and I GUI into that. And you could do it CLI, but no. And then the wireless LAN controller pushes that configuration to the lightweight access point. So in lightweight mode or in a lightweight architecture, all APs are deployed and managed centrally from the WLC, really simplifying the network management and thus reducing the cost when you have an expanded wireless network. Meaning that it cuts down on what's called like OpEx, your operational expenditures, because now we don't have to worry about a couple or 3 wireless engineers managing 50 autonomous access points and doing the coordination themselves. You can do it all from one central location, and that is a WLC. And that WLC in lightweight mode is going to typically sit on your campus network. Okay? So that means these lightweight access points, they're connected to your distributed system, so probably an access switch. And then that wireless LAN controller should be probably in the core or distro layer of your Cisco 3-tier topology. And then all the traffic, and we're going to get into this, that's sent from any Wi-Fi enabled device or Wi-Fi client is actually going to get sent back to the wireless LAN controller via these CAP-WAP tunnels that we're going to go over. So contrast this to autonomous access points where If both these clients were sitting on the same SSID, let's say sales, and they wanted to talk to each other, PC1 and PC2, they could just stay local here. But in a typical lightweight mode architecture deployment, even that data flow, if they're connected on the same SSID and the same BSS, they're still going to traverse these CAPWAP tunnels back to the wireless LAN controller, and that wireless LAN controller is going to direct that traffic. And we're going to go over this a little bit more in the upcoming slides. So lightweight access points, or LAPs, split the functionality of autonomous access points by only taking the role of real-time functions. So those real-time functions are the RF transmissions, right? The client roaming and association, the Wi-Fi encryption and decryption. So what we mean by that is the actual encryption that's going to be sent on those 802.11 frames, the actual processing of that. The hardware processing is still done at the access point, but the wireless LAN controller tells it how it wants it to allow client roaming, association, and Wi-Fi encryption. So it's still getting its configuration from the wireless LAN controller, but some of the real-time functions are happening at the access point. So like the layer 2 frames, right? The 802.11. The association process is still happening at that lightweight access point. And then when it's doing this WPA2 or 3 encryption, it's happening there. It's just getting the settings from the WLC. And then how does that lightweight access point actually connect to the wireless LAN controller? It's going to use something called CAPWAP, which I don't remember the actual acronym, what it stands for now. It's something like access provision, wireless access points, something like that. We're going to see in the next slide. But essentially, these CAPWAP tunnels, we're going to have 2 of them. And when this lightweight access point initially boots up, so you plug into a switch, it gets its PoE, and if this access point's operating in lightweight mode, it's going to boot its image, and then it's going to go through 5 different methods of trying to establish a CAPWAP connection to the WLC. And that first CAPWAP connection is going to be a control. So it's going to build a CAPWAP control tunnel using this UDP port. And once it establishes that control tunnel, the wireless LAN controller uses that control tunnel to push all of its configuration and its image, right? Or its new profile, essentially, is going to be pushed across that CAPWAP control tunnel. And this CAPWAP control tunnel can be encrypted, as well as this data tunnel can also be encrypted using something called DTLS, which is essentially TLS but for layer 2. And that's because this CAPWAP control tunnel just encapsulates that layer 2 information, so we can protect it using DTLS, which is again just TLS but at a lower layer, not at layer 4, which you typically see with TLS. Okay, so lightweight access points. A little bit more on how they discover the WLCs. So they're going to go through several different states to discover the wireless LAN controllers and then build the CAPWAP tunnels. So right now we're not going to get into the different 5 methods it goes through. We're actually going to just go through the entire flow to get the lightweight access point in a run state. And when you're doing this live, you're doing this on actual equipment, and we're going to have bonus videos of this. The lightweight access point, at least for Cisco, you're going to have lights on there. Typically, you're going to have red, blue, and green. And you're going to see these flash, and the different flashes and light colors are going to tell you actually what stage the wireless or the lightweight access point is going through. So if you actually if we go to Google real quick and just type in Cisco 3700 AP light codes or LED patterns, you typically, this is just a quick search, but it'll tell you what these flashing colors mean, right? So if we come down here, let's see, we just Control F light. That's not gonna give us good stuff. Let's LED Cisco 3700 AP LED status table. Well, anyways, you get the picture. There's tables that go over this. I was just looking at one, and I wish I could remember. But anyways, so you can see the LED stages can actually represent something. So when you're actually doing your deployments live and in person, you can see each of these steps. So step one is going to be that lightweight access point boots up. It's going to download its initial image, and then it's going to go through 5 different methods of discovery to discover the WLC. And then once it does that, it's going to build a CapWAP control tunnel encrypted with DTLS to the wireless LAN controller. The wireless LAN controller is going to receive that CapWAP join connection essentially, and then it's going to accept it or deny it, and then it's going to join the wireless LAN controller network. And again, it's going to do this on its control CapWAP tunnel, which is using port 5246, which is also encrypted by default. And then once it's joined to that WLC network, it's going to download either a new image, so maybe it needs to get updated with a new image, some new firmware, so to speak, and actually get its configuration from the WLC. And anytime this WLC makes a change, like let's say you create a new wireless local area network, it's also going to use that CapWAP control tunnel to push that new wireless LAN that it wants that access point to advertise, a new SSID, right? And then once it gets its configuration and it's fully up and running, we call that the run state. And that's typically going to be like a solid green color or maybe even a solid blue color on the access point, depending on your access point model. And then once it's in the run state, it's going to build that data tunnel. And that's going to be sending, you guessed it, all the data traffic from any of its clients that are connected to it. Okay, so kind of diving deeper into this step one here. How does it do its discovery? How does that access point actually create that CapWAP control tunnel? So the first thing it's going to do, if it doesn't have in its flash memory a wireless LAN controller remembered and that it can reach it, it's going to go through these methods. So what are we talking about here? So let's say like you have a power outage and then the wireless and then power comes back on. The lightweight access point in its flash will have it memorize the previous wireless LAN controller is connected to. And if it can still reach that wireless LAN controller, it'll just go connect. But if it doesn't, imagine this is a brand new AP out of the box, a brand new wireless network that we're configuring and building. These are going to be its methods of discovery. So method one is it's going to just send a broadcast. So all 255s, if we're doing IPv4, and it's going to attach that CapWAP control port number. And then if that wireless LAN controller is sitting outside of the lightweight access point's broadcast domain, you can also set up an IP helper address with this command coming before it, IP forward protocol UDP 5246. So let's say this layer 3 switch, if this sits on like, let's say VLAN 10, this wireless access point, and this sits on VLAN 20, you can actually forward that broadcast to the wireless LAN controller and it'll send it via unicast. And then this wireless LAN controller will respond and it'll make that connection. If that doesn't work, the lightweight access points, if you actually get into the CLI of it, because you can console into these access points as well, you can actually set the primary base. Essentially, you're just statically setting it, saying, hey, Kay, I need you to connect to this wireless LAN controller that sits at 10.1.1.1. Method 3, the lightweight access point can remember previously joined WLCs and attempt to rejoin. So this is different than what I described up here because this is going to be its first check. This is like, okay, let me go back to deep in my memory and see if there's any I joined like months ago and attempt to rejoin. Method 4, which is a very common one, the one you're going to see like honestly more than any of these because this doesn't scale very well. This you run into issues kind of. method 4 is going to be just setting this access point in a VLAN that is using DHCP and setting the option 43 address, which essentially means when we do our DORA process here as an access point, we're going to get the option 43 attached to that DHCP like response. And we're going to say, okay, DHCP servers tell me that my wireless LAN controller sits here because of that option 43 address. And then if that fails, we're going to send DNS requests out for this name to see if any wireless LAN controller is listening to that and to respond. And that's kind of like the default, right, name for a wireless LAN controller. So those are going to be the methods that a lightweight access point connects to a wireless LAN controller. And then CAPWAP. So now getting into the actual CAPWAP tunnels. So CAPWAP stands for Control and Provisioning of Wireless Access Points, and it is a tunneling protocol, meaning that the CAPWAP header gets encapsulated, you see that here, over our original UDP packet, okay? So it encapsulates data between the lightweight access point controller with new IP headers, and then the access points in WLCs are actually going to build two tunnels, a control CAPWAP tunnel and a management CAPWAP tunnel. The control, again, using UDP 5246, and then the data using UDP port 5247. So you can see here CAPWAP is a tunneling protocol because we're encapsulating the original IP packet. So earlier I said layer 2, I meant layer 3. It actually encapsulates the IP packet. So when we do that DTLS, that's like layer 3 TLS. So my apologies. So CAPWAP control tunnels are encrypted using DTLS with X.509 digital certificates. Oh wait, I guess it is layer 2. I'll just cut that out of the video. But yeah, layer 2 TLS. Then CAPWAP data tunnels are not encrypted by default, but they can be encrypted using DTLS. So you can enable DTLS on these CAPWAP tunnels. And then all client traffic is going to go to the controller first, even if two clients sit on the same AP. So what are we talking about here? So if I have PC1 here and PC2, and they're on the same VLAN 10, and they're connected to the same SSID, I said BSSID, which is like, let's say, Wi-Fi 10. Even if they need to talk to each other, they're going to go over this CAPWAP data tunnel. It's not going to do local switching of those frames there. Now, there is a possibility in your lightweight architectures to enable something like this, but just the default, right, for testing is that all traffic goes to the controller first. All right, now going over cloud-based access points. So we just touched on autonomous and lightweight, and now cloud-based, I like to teach right after lightweight because very similar. So cloud-based access points are going to be managed and controlled through a cloud-based dashboard. And they're going to be the access points that are being controlled by this cloud, right, are going to be deployed and provisioned remotely, which is going to really simplify your management costs. Because now instead of having OpEx, which means that we have operational spending on maintaining wireless LAN controllers on premise, having actual engineers that need to be on premise to fix them, now we just do everything in the cloud. So for any small to mid-size or even large businesses, cloud-based APs are awesome. They're low cost and they're really easy to manage. So a great example of this is Cisco's Meraki APs, really built for that small to mid and getting into the kind of large enterprise systems where you just have a cloud dashboard through Meraki, and as long as these APs are connected correctly and can reach out to the internet, you're controlling and deploying those access points. So really, lightweight and cloud have a lot of similarities. They're all controlled from a central place, but with lightweight, that WLC sits on your on-premise network. You may not want to be able to reach it over the internet. You may need a VPN, right? Especially if it's your protected enterprise. Where cloud, I mean, I could sit on my beach house in Hawaii and now I'm managing my whole wireless infrastructure. Then the cloud-based vendor, with any really cloud deployment, what you're doing is reducing the need for on-site IT staff. Now what you're worried about is called capital expenditures versus OpEx. Essentially meaning that now the cloud-based vendor is providing the management and security features. It's pretty much a software as a service at this point. And they're maintaining the data center. Now, all you're worried about is maybe for each access point you add into your network, they're going to say, okay, well, if that access point stays up for 24 hours, that's going to be an additional $10 a month for you using our service. So with that, they can be scaled up or down easily, though, to meet changing business needs. To where maybe after hours, we just go ahead and turn those APs off, and then someone has to submit a request for us to turn them back on. So we have that scalability, right? Or maybe we can do some sort of automation where that if somebody badges into the office and we see that they log into the computer, we can set up some script that says, okay, hey, my cloud dashboard, activate these APs. So we can really have that scalability. And with cloud-based APs, all you need is an internet connection to communicate to that management dashboard. So now again, saving on your operational costs because now you don't have to update your wireless LAN controller's firmware, licensing. You don't have to do that now. You can do it from your beach house in Hawaii, all from your computer. So pretty cool. Cloud-based APs, I think, are the future. And I think Cisco, the reason sometimes in their training they say that that's for mid-sized businesses is because their on-premise gear still gives them a lot of, retains customers a lot. But Meraki, I mean, I've seen large enterprises use Meraki and it's great, right? Of course, maybe you run into some not scalability issues, but maybe not as robust. You can't handle, more than like maybe 3,000 APs. Where if you deploy those beefy wireless LAN controllers and high availability, lightweight mode may be the option if you're doing like an airport or if you're doing like a skyscraper office building that shares the same internet. You own 20 floors. There's give and take with it. But cloud-based APs are probably the future for most businesses. All right, and now getting into actual wireless LAN controller deployments. So the first one we're going to talk about is unified. And this is going to be where you see actual hardware appliances deployed on your LAN. So compare this to embedded, where instead of buying an actual WLC, a hardware appliance, you just install the WLC software maybe on like a switch or something or into the actual access point. With unified, you're actually buying that physical hardware. Compare this to also virtual, where you can actually deploy a virtual WLC, like maybe on your ESXi Type 1 hypervisor, and that's managing all your lightweight access points, and it's not a physical appliance. So unified is going to be your most robust solution, however, though, and it can support up to about 6,000 APs, and they can also be deployed in what we call kind of like a server cluster. We have 2 wireless LAN controllers here that can be doing what's called high availability. So you'll have, there's actual terms for this, but essentially your primary WLC and your secondary WLC. I think it's like hot standby. There's actual terms for it. I'll look it up and put it in the description on the YouTube video. But essentially this WLC is your primary, handling all those CAPWAP tunnels. And if this goes down through this high ability SSO is what we call it, this secondary WLC maintains that same list of CAPWAP tunnels and can immediately take over. So you can kind of deploy and have this redundancy with your WLC unified network. So again here, so 2 controllers can be paired together using high availability with stateful switchover. That's the SSO. And then, so during the boot up, we have one that is active, and then that's called standby and hot. So the hot one is the active WLC, and standby is the one that's waiting for that WLC to fail so it can take over. So both controllers are going to maintain that list of known APs, that kind of like that stateful list of all those CAPWAP connections. And the standby takes over all those CAPWAP tunnels if the hot one or active one comes down. And then you see here, you see a unified Cisco suite of hardware appliances. So something like these two guys right here, probably going to be for your small to mid-sized businesses if they want to run on-premise infrastructure. This is probably going to be for your medium to large. And then this beefy boy is probably going to be when you have those thousands of APs, and you're going to want to probably buy two. Always want to buy two if you're going to deploy on-premise infrastructure, because one is done, two is one, right? But this is what an actual WLC looks like. And then I'm going to bring my camera into view here and actually show you the WLCs I have. So one sec. So for this, older equipment is perfect for labs just at your house. They still run like 802.11 AC. You can still get Wi-Fi 5, good security. But this is kind of one of those mid-sized to larger WLCs. It's a 5500. In our next series of videos, we'll actually go over what all these ports are on here. But you see it's SFP ports or modules. So we can get probably like, 10 gig, not 40 gig, but that twin ax fiber connections that can probably give us a lot of throughput and bandwidth. And then again, I bought this, I think off Amazon or eBay, maybe $500, and it came with 3 Cisco access points. And then we have this little guy right here. This is what you're going to see in a lot of other training videos. Just a simple 2500 series access point. You can see not as robust. It just has console and then these management ports right here. So we don't have any out-of-band management on this one. More to follow on that. But again, great for home labs. You'll probably get 5 access points on this on the base license. So it's good. It's good. It only cost me again, $400 to $500. Came with 3 access points. And it lets you actually see a deployment of a unified Cisco WLC, even if it is EOL. That means end of life or legacy. All right. So that is going to conclude this lecture. So stay tuned for our next one. We're actually going to do some configuration, wireless LAN deployments. It's going to be really awesome, really fun. And again, I want to thank you for viewing. And if your unit, organization, or your team ever wants in-person or virtual training with Trepa Technologies, please go to our website in the description below, and we'd love to train you and your team. Thank you.